So in this video, we're going to look at similar shapes and the similar volumes. You've probably already done a video on similar areas. So similar volumes. Now you can see here that our shapes, before we even begin to work out the volumes, are 10 to 12. So the ratio of the sides, or one dimension, is 10 to 15. So if we divide both of those by 5, our ratio is 2 to 3. So that's the ratio of the sides, remember. Now to work out the volume of cone A and the volume of cone B, we're going to use this formula up here. So the volume of A, that's a third times pi times r squared. The r is the 10, so that's 100. And then we're going to times it by 8. So that's 800 pi divided by 3. Let's do the volume of shape B. So that's the same thing. It's going to be a third pi. Now 15 squared is 225, and then I'm going to times it by 12. And this is going to end up giving me 225 times 12 divided by 3 gives me 900 pi. Now what I want to do is I want to compare the volumes of these two and have a look at the ratio of the volumes of these two. So here we've got 800 pi over 3, and here we've got 900 pi. So what I'm just going to do is simplify this. I can get rid of these pi's and I can have that as 800. I can multiply the other side by 3 to make it 2700. And let's get rid of those zeros. So this gives me a ratio of 8 to 27. Now let's just compare that with what we started with, which is the ratio of the sides or the radiuses or the height or one dimension is this for the sides. But we've just found out that we've got 8 to 27 for the volume. And that's because volume uses cubic meters. So we're basically cubing each of the ratios of the one before, the sides. So if we cube, 2 cubed gives me that 8, and 3 cubed gives me that 27. So if we have the sides, the volumes are the cubic ratio of those sides.